Friends, one more property here that is depend upon BPT. This is called as application of BPT, which is called as angle bisector property. That is a statement here. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. So what is that? There is given to us one ray which is angle bisector of one of the angle of triangle they are given to us. Okay, we'll discuss here. First of all, from the given information, we are going to draw the figure. See here. This is triangle ABC. Okay, in which they were given to us. This is the ray which is bisector of angle and which intersects opposite sides at point D. Okay, see here. The given part we write. In triangle ABC, ray AD is angle bisector of angle BAC. Okay. Now that D is such that B dash D dash C. This is the part which is given to us. Okay. Now what we have to prove here? We have to prove this bisector intersects the side BC at D. So that BC is divided in two parts. The ratio of that two parts, which is BD upon DC, which is equal to remaining sides of the triangle, which is BA and AC. The ratio of that BA and AC and this BD upon DC, both these are equal. That much part we are going to prove here. See here, BA and AC, this one which is equal to BD upon DC, that part we are going to prove here. Okay, let's see. Here also we are going to make some construction. That is very important. Why we are going to make some construction? Because already we know that BPT. So BPT we have to apply. For that we need some parallelness in a triangle. So such kind of constructions here we have to make. Which construction? See here. From C, we are going to draw one parallel line to this AD. See first. Okay. See. This is the parallel line. Okay. To AD. And again extend this BA. Just extend. This is just see here. That is a parallel line and which is exactly collinear. Okay, like this one. Here they meets at point A, B, C, D. We write some name here. E is there. Understand? What is our construction? This AD which is parallel to C, which drawn from C, and they meets at E. This is the construction part. I'll write first construction. That is also very important thing. Draw C parallel to AD through point C, B dash, A dash, E. That is very important. Okay, that much part is enough to see which construction we made here. Okay, by using all this construction, try to observe here. Here, the proof we need for that, just observe exactly where we are going to observe here. See here. Whether you are going to see here triangle BEC, you are observing here this big triangle. Okay, the name of that one BEC, in which this AD is here. AD is here, which is parallel to EC. Just in construction part, they given to us. Okay. Whenever in such kind of triangle, if this part is parallel to one of the side, then always try to apply BPT. Now it is very easy to apply here. See first, this BD upon DC, which is equal to BA upon AE. This is the first part. But we need what? BD upon DC, okay. BA also okay. We know AE, but we need AC. Where it is AC? This much part is AC. That means we have to prove both these are same. If we prove AE and AC, both these are same, equal, then the proof will be completed. Now the next part is what? How we can prove this AE and AC, both these are same? We know they are the sides of one triangle. This is the triangle, in which we are going to prove the two sides of the triangle. We're going to prove they are congruent. Okay, when they becomes congruent, we know if we prove their opposite angles are same. If we prove these two angles are same, then these two sides are same, because we know isosceles triangles theorem. That one told us so. Okay, AE and AC become same. Now replace AE by AC, then the proof will be completed. Understand? Let's hear by step, we'll write first. Okay, see first. Statement number, statement and reason. Yes, every time don't forget to write the reason, which is very, very important. See first. Where we are going to observe here in this big triangle. Which triangle? BEC. Okay? In triangle BEC, in which what we know, AD is parallel to EC. AD is parallel to EC. It is construction by construction. Okay? Because of construction, it is parallel. Now we can apply BPT here. See, what is that BPT? How can apply here? BD upon DC. Just try to apply very carefully. BD upon DC is equal to BA upon AE. BA upon AE. This is from 1 and by BPT. Okay? Now, only we have to replace this AE by AC. The next part, which we are going to prove AE is equal to AC, then replace AE by AC. That will be the proof. Okay? Now, the next part. We know here, these are the two sides or lines, they are parallel. And whenever the parallel, we know corresponding angles, alternate angles, even interior angles also. We can apply now these two all these angles or properties here. See first, here these two are parallel to each other. We know this is the angle which is congruent to this angle. Understand why these two angles are congruent? Because of corresponding angle. Okay. Next part is what? This angle is congruent to this angle. Why these two angles are congruent? Alternate angle. But we know these two angles are congruent in given part because of AD is a bisector. That means these two are congruent, these two are congruent, but these two are already there given to us congruent. Therefore, these two becomes congruent, and that is the proof. Okay? Now see that. First, we'll write corresponding angle. Which one? BAD angle BAD congruent to angle E. You can write by one letter. This is from 1 and corresponding angle test. Yes, this is very important one. Corresponding angle test. After that, we can write now alternate angle. Yes, which one alternate? DAC and angle ACE. Angle DAC congruent to angle ACE. This is again from 1 and alternate angle test. Okay, these short forms just very carefully try to listen. This is corresponding angle test and it is alternate angle test. And remember, this is possible only if the two lines are parallel. Okay, remember. Now, we know this BAD and DAC, both these are congruent. Both these are congruent. Why they are congruent? Because in the given part only they are given to us. Okay, see first. But angle BAD congruent to angle DAC, which is given. Okay, where it is given? Because of C here. This ray AD is the angle bisector, means the meaning of that one is nothing but these two angles are congruent. Okay, so by using fifth step, see here. Because of these two are same, they are here, and these two are same, then we can write these two are congruent. So the next step, angle E congruent to angle ACE. This is from third step, fourth step, and fifth step. Now E and ACE, both these are congruent. They are here, and because of these two are the angles of same triangle, therefore their opposite sides are same. Means which two sides are same now here? AE and AC, both these are same. AE equal to AC. This is nothing but from 6 and isosceles triangles theorem. Remember this one. This is one of the very important property. So many times we are going to apply this property. Okay? Now the last step. Just listen very carefully. AE equal to AC. Both these become same. Now replace this AE by AC. That will be the proof of this angle bisector property. We'll write. Therefore, BD upon DC is equal to BA upon, don't write now AE because AE is equal to AC. Replace AE by AC by using 7th step. So from 2nd and 7th step, the proof will be completed. Understand? This is one of the very, very important property. So many examples are depend upon this property. Okay, friends, we'll apply this. See here, students. Let's start for practice set 1.2 here. In this one, we are going to apply all these property what we just learned: BPT, converse of BPT, ABT, three parallel lines and an intercept property. All these property we are going to apply. So now, in the first example, in all these three figures, we are going to check, we are going to determine whether the ray is bisector or not. That one we are going to check. So by that property, by which property we have to apply? Angle bisector property. For that, what we need? See here. First of all, in first figure, just see here in first figure. See here, all this QM, MR, QP and PR, all the parts are there given to us. To prove this is the bisector, what we need? We know ABD. What tells us? This upon this is equal to this upon this. Let's check whether they are same or not. First of all, we'll write here QP upon PR. Okay? That remaining sides ratio we are going to take. Well, how much this one? 7 upon 3. This is first part. Then this side, QM upon MR. Remember friends, if we take QP first, then we have to take QM first. If we take PR first, then we have to take MR first. That is very important. That is called as corresponding. Just remember here. What about QM and MR? QM 3.5. What about MR? 1.5. Look here. This is not equal to this one. Okay, but we can make first. So, denominator and numerator both have one digit only decimal. We can remove straight away because both have same number of digits here. See how? 35 upon 15. Whether both these are divisible by any same number? Yes, by 5s are. So 5 3s are, 5 7s. How much here? 7 upon 3. Which is equation number 2. Whether 1 and 2 are same? Yes, therefore we can write from 1 and 2, these two are same, then we can write this QP upon PR is equal to QM upon MR, both these are same. And when these two are same, then we can say this ray PM is angle bisector of angle QPR. Understand? Yes? Very similarities. In that example also, I write down directly here. See first here. RP upon PQ, that is 7 upon 10. This side, RM upon MQ, that is 6 by 8. Whether it is divisible? Yes, by 2s are. 2 3s are, 2 4s are. Means 3 upon 4. This is 2. See here, from both these, they are not equal, so these two are also not equal. Therefore, it is not angle bisector. Understand? Similarly here also. I'll take here first QP upon RP, which is 9 upon 10. It is not divisible by any other number. So keep as it is. Now this side, QM, yes, upon MR. What is QM? This is 3.6 upon 4. Now look here. Similarly, here both have numerator and denominator same number of digits, but here only numerator. For that reason, I am going to make like this. Is it okay? Now just remove the decimal point, that is 36 by 40. Now tell me by which number both these terms are divisible. Obviously by 4s. See here, 4 10s, 4 9s, means 9 upon 10, which is equation number 2. Again both these are same. That means these two are equal. Therefore this middle ray PM is angle bisector of the given angle. Understand? Like this we have to verify whether the given ray is bisector or no. Okay? See here, the next example. That is second one and third one. I draw the figures on board. See here, in this figure, what they are given to us in triangle PQR. There, this MN is there, P dash N dash R and P dash M dash Q. They are given to us. This PR is 20, NR is 8, PM is 15, and this full PQ is 25. From this much only information, we are going to determine, check whether this MN is parallel to QR or not. Now see here, to check the lines are parallel or not, which property we have to apply? It is converse of BPT. For that converse of BPT, what we need? The ratios are same. Then we can say these two are parallel. Okay friends? Now see, just check whether the ratio is same or not. But very carefully, this full part is given to us. Means we have to first find Pn. Similarly, we have to find MQ, and then we will take the ratio. So how can find? This is very simple. P dash N dash R, in which PR is equal to Pn plus NR. Now just put the values. What is PR? Which is I think 20. Pn we have to find. NR 8, means 20 minus 8, which is Pn, that is nothing but 12. Now very similar this side, P dash M dash Q. Here also PQ is equal to PM plus MQ. Now we'll put the values. What is PQ? That is 25. PM 15. And MQ we are going to find. Tell me how much? That is 10. Okay? After getting all this, let's take here one by one. Just take one side ratio only. That is Pn upon NR. What is Pn? We just find that is 12. What about NR? 8. So both these again divisible by 4s. 4 3s, 4 2s, which is 3 upon 2. And then we'll take one more, that is remaining pair, which is Pm upon NQ. So that much 15 upon 10. Again both these are divisible by 5s. 5 3s, 5 2s. So 3 by 2. Now look here, this is equation number 1, equation number 2. So from 1 and 2, both these are the ratio which are same. Pn upon NR is equal to Pm upon NQ. Therefore, what you can write? This Mn is parallel to QR. So by, yes, by which property? Converse of BPT. Okay, every time which property we applied, that property try to mention every time. Okay, that means you cannot lose the marks. See here, is any doubt here? Very simple it is. First of all, try to find a which is not given part, that will first find, and then try to apply this procedure. Similarly, in this third example, in which we are going to find this QP. They were given to us, this MQ is 2.5, MN is 5, PN is 7, and some information is extra is given to us. This is NQ, which is a ray, and that is bisector of M and P angle. Now it is given. We don't want to determine whether it is bisector or not. No, it is now given. Okay, so because of the given thing is there, we can apply that angle bisector property. So first of all, in triangle MNP, in which NQ is angle bisector of angle MNP. So by angle bisector property, okay, so we can apply now here. So therefore, Mn upon Pn is equal to Mq upon Qp. Just try to put the values here. What is Mn? 5. Pn 7. Mq 2.5. And now Qp we are going to 5. See here. Now it is one of the very important part. Go with cross multiplication. Go with cross multiplication and try to find QP. So how can find that one? See here. Just go with cross multiplication. 5 into QP is equal to 2.5 into 7. So we need QP. So take this 5 to that side. Means 2.5 into 7 upon 5. So just simplification. 5 ones are 5. 5 zeros are. Okay. And then 5 fives are. So here it is QP, which is equal to 0.5 into 7. That is nothing but, yes, tell me, 3.5, which is QP. Okay. Like this we can find, we can use all these properties. They are very, very important. See here, by angle bisector property. In the previous one, this is converse of BBT. Like this we can apply all these properties whenever we need. So always try to observe which property we have to apply, where we have to apply, how we have to apply, and when we have to apply. All these are very, very important. Understand? We'll take now remaining examples. Friends, now the next example is here, ninth sum of the practice set 1.2 here. Here in this figure, they are given to us A, B, C. This is a triangle in which ray BD is a bisector is given. Now the remaining information is like this. From this we are going to find the value of x, which is very, very, very simple one. Okay, see here. How can solve? In triangle ABC, BD is a angle bisector. BD is an angle bisector of angle ABC. Okay. Now by again angle bisector property. Very easily. We know here. Yes. AB upon BC, which is equal to AD upon DC. In which only we have to put the values. What about AB? X is there. BC, x plus 5. This side, x minus 2 upon x plus 2. Okay? Now just go with cross multiplication. Let's see what we get here. See here, x into x plus 2 is equal to x minus 2 into x plus 5. Okay? Observe here. Now multiply to each term. X square plus 2x. This side, x into x, x square, x into 5, 5x. Now 2 into x minus 2x. Again minus 2 into 5, that is minus 10. Just by observing here, both sides x square term is there. That one just reduce here. Now take all the x together. 2x minus 5x plus 2x, which is equal to minus 10. Okay. Now tell me how much you get here. 2x, 2x, 4x minus 5x, which is minus x, is equal to minus 10. Therefore, x equal to 10. It is very, very, very simple. It is possible. And in next example, we'll take now 11th sum, which is one of the very best and very important one. See here, in triangle ABC, ray BD bisects angle ABC and ray CE bisects angle ACB. If AB and AC both the segments are same, then prove that ED parallel to BC. See here, we'll draw the figure first. ABC is a triangle in which what are given to us? Ray BD bisects angle ABC. Ray BD bisects angle ABC. Okay, and ray CE bisect angle ACB. Ray CE bisects angle ACE. We'll write here first BD and ray CE. So from this information, and with the same time they are given to us this AB which is equal to AC also given. From that we are going to find this ED which is parallel to BC or no, that one we are going to verify. See first, I'll write first given part. What is given? In triangle ABC, ray BD is angle bisector of angle ABC. Okay, ray CE is again angle bisector of angle ACB. Okay, and this is not only enough, they are given to us sec AB is equal to AC also they are given to us. Now what we have to prove here? We have to prove, yes, ED is parallel to BC. That one we are going to check. Means we have to join this ED also. Okay, let's see that. 2 times we are going to apply angle bisector property, which is very simple. See here how we can write. See first, ray BD is the bisector. One by one we can apply here. Ray BD is angle bisector of angle ABC. Means it is given, we can apply angle bisector property. What is that? AB upon BC is equal to AD upon DC. Just think that much part only. AB upon BC is equal to AD upon DC. This is from 1 and angle bisector property. Okay, now in the similarly next part is what? Ray CE is angle bisector of angle ACB. Look how easy it is. This is also given. Now the next part, apply again here also angle bisector property. Okay, look here. So which property we can apply here? Angle bisector property. What we can write now? AC upon BC. AC upon BC, which is equal to AE upon EB. AE upon EB. This is again from 3 and angle bisector property. See here, how can prove this one? Okay, what is the given to us? This CE and BD, both these are bisectors, and AB equal to AC is given to us. Using that concept, we can prove that one. Okay, see first, one by one, we can write. First of all, ray BD is angle bisector of angle ABC, which is given to us. So apply angle bisector property. What is that? AB upon BC is equal to AD upon DC. Just see that much part only. AB upon BC, which is equal to AD upon DC. This is from 1 and angle bisector property. Similarly, ray CE is angle bisector of which angle? ACB. See here, ACB, which is given. Now here also apply the same property. Yes, tell me what? AC upon BC is equal to AE upon EB. Okay? AC upon BC is equal to AE upon EB. This is from 3 and angle bisector property. Now just try to observe here in second and fourth step. See here, what we need to prove these two are parallel, we need AE upon EB equal to AD upon DC by converse of BPT. Okay? Now look here, AE upon EB means which part we have to prove here, and AD upon DC means which part we have to prove here. See here, if we prove AD and DC, AD upon DC and AE upon EB, we are going to prove they are same. Okay? To prove these two are same, that means we have to prove these two are same. Already denominators have same. AB and AC, that is the given part. See here, AB and AC, they are given. So but we can write now here AB equal to AC, which is given. Now from all these three steps, which three steps? Second, fourth and fifth. This AB equal to AC, we can write here. That means we can prove, that is which proved one side is same. That means automatically that other side is also same. Therefore, the last step what tells us? AD upon DC, which is equal to E upon EB. This is from 2, 4 and 5. So this is converse of BPT. What tells us? This upon this equal to this upon this, then ED parallel to BC. Hence, we can write now ED parallel to BC. This is from 6 and converse of BPT. Like this, so many times we have to apply with all properties in the given examples. Understand?
Hello. Hello friends. Now we are going to take remaining examples from practice set 1.2. Okay? Already we solved some examples. Now we'll take remaining of them. See here. This is the fourth sum in which triangle ABC is there and middle the PQ is there and two angles are given. Angle APQ 60 and 60. Here it is. B is also 60. Measures of some angles in the figure are given. So we have to prove this part. AP upon PB is equal to AQ upon QC. Okay. For that, what we need? See here, this angle P and angle B, both these are corresponding angles. And if the corresponding angles are congruent, then straightway we can write this PQ and this BC, both these are parallel. Okay. So because of these two angles are congruent, we can write these two are parallel to each other by corresponding angle test. Therefore, if in a triangle PQ is parallel to BC, then apply by BPT, we can find AP upon PB is equal to AQ upon QC. This proved the given. From the given part, we can prove this part. Okay. We'll take next sum. See here, in this example, trapezium ABCD is there, in which AB, PQ and DC, these three are parallel to each other, and AP is 15, PD is 12, BQ we have to find, QC is 14. So from all this information we have to find BQ. Yes, now here this AB, PQ and DC, these three are parallel to each other. So we know the property by three parallel lines and their intercept, we can write the ratio, that is AP upon PD is equal to BQ upon QC. Okay. Now just put the values 15, 12, 14 and from that by simplification we can find the value of BQ is 17.5. Okay. This is very easy example. We'll take next one, sixth one. In this figure, QP we have to find using the given information in the figure. See here in the given figure, what they given to us? In triangle MNP, this NQ is bisector and here Mn 25, Np 40 and Mq 14. So from that we have to find this Qp. Again, very simple it is. By angle bisector theorem, here NQ is angle bisector of angle MNP. Because of that one, by angle bisector theorem, we can write the property MQ upon QP is equal to Mn upon Np. So again, now put the values here and try to simplify. We'll find the value of QP, that is 22.4. All these are very simple examples. Again, in the next sum, here in 7th sum, AB, DC and EF, all these three are parallel to each other. So again, here it is DF 4, BD 8, AC 12 and CE X. That is X we have to find. Afterwards, AE also we have to find. See here, these all three are parallel to each other. Therefore, by three parallel lines and their intercept, so FD upon BD is equal to CE upon AC. Okay. Again, now put the values 4, 8 and here 12. We can find the value of X. So by simplification, we find the value of X equal to 6. Now by betweenness, A dash, C dash, E, that is AE equal to AC plus CE. We'll put the value 12 plus 6, that is 18. Okay, like this we can find the values what we have to find, this X and then AE. Okay friends, now take the next one, which is 8th sum. Again here in the triangle element, ray MT is a bisector. Okay, and if this LM6, MN10, TN8, and from that we have to find LT. Again, it is very simple. Used by angle bisector theorem, this LT upon Tn is equal to Lm upon Mn. Now we'll put the values. Only we have to find LT. Now try to simplify. We'll find the value of LT is 4.8. Okay. And now in the last sum, in which there is one activity. Here in the triangle DEF, okay, X is in the interior of triangle DEF. Now point X is joined to every vertex XD, XE and XF, and afterwards P, Q, R are the points on that XD, XE and XF respectively. So here this PQ is parallel to DE is given to us, and this QR is parallel to EF. From all that information, we are going to prove this PR is parallel to DF. That is our aim. See here, only we have to fill the blank spaces. See first here, this triangle XDE, where it is XDE. Here it is this triangle, in which PQ is parallel to DE. Okay, so it is what we have to fill up, tell me. Yes, here we have to fill up. See here, we have to fill up here. Yes, PQ is parallel to DE. So it is given part. We have to write given. Okay. Afterwards, here XP upon PD we have to use BPT. So XP upon PD. Okay. And that side XQ upon QE. Here we have to write XQ. Okay. Now afterwards in triangle XEF, here it is XEF. See here this one XEF, in which this QR is parallel to EF. Again it is also given part. Again here also given. Okay. Now here we have to use by BPT. This part we have to write as it is here. Okay, by BPT. See here how to use all the properties what we learned in this topic. XE F means XQ upon QE. We have to write here XQ okay, upon QE, this side XR upon RF. Okay, like this we have to fill the blanks. Now, by using this first step and second step, if you observe here, this much part xq upon qe is in both the equations. That is why we can equate this one, xp upon pd is equal to xr upon rf. So we have to write here it is xp upon pd, very carefully, and decide xr upon rf. Okay, like this. And from this, where is these are xp, where it is xp upon pd is equal to xr upon rf, means whenever these two ratios are same in a triangle, then by using converse of BPT we can write this PR is parallel to DF. Understand? Look, very simple examples all these are. Okay friends, thank you.